Welcome to the lecture on principles of equivalence. So, in engineering economic analysis, we need to find the equivalent amount at different times. So far we have discussed about different interest factors. Now, the equivalence means, by definition, two things are said to be equivalent when they produce the same effect. Means, if we try to compare two things which are different, we cannot say that they are equivalent unless we compare them on a certain basis. Suppose we try to find the equivalence between 500 rupees and 10 kgs of sugar. So, unless we know the price of 1 kg of sugar, we cannot find the equivalence between the two. So, we have first of all to have a basis, then only we can have the equivalence. For comparing two different situations, the parameters to be evaluated must be placed on equivalent basis. So, basically the end effects has to be considered if suppose there are two different things and they have to be judged. In that case, the effect they produce, they are to be seen with a common eye. So, in engineering economic analysis, basically what we deal with is, we used to see the cash flows at different times. Now, we have basically to say whether two cash flows are equivalent, or even in a single cash flow, what will be the equivalent amount at a later time, because anyway we have discussed about the time value of money. So, basically value of money which is there now is going to change at a later time. So, basically there are three things which are dictating it. One is amount of sums. So, basically in any cash flow diagram, what you see is amount of monetary transactions, then the times of occurrence of these sums. They may occur at the same time or they may occur at different times, and then the interest rate. So, all these three is to be taken into account. Now, let us see one example where you are given an option of getting a reward from your organization. The organization gives you two options. One is that you get rupees 50,000 now. Another option which the organization gives you is that you get rupees 8,000 per year for the next 10 years. So, every year the payment will be made at the end of the year. So, basically in this case, if you look at, you are basically getting 80,000, but for the next 10 years. Now, how to evaluate which of the option is better economically? You will have to see that what is the equivalent amount at a particular time. In this case, what we see is, as we have seen in the earlier case, you have three things: amount of sums, times of occurrence of sums, and interest rate. So, if two of the things are equal, the third thing will anyway be equal for any cash flow diagram. If there are two cash flow diagrams and if the two of the three is same, the third has to be the same or the fixed one for the two cash flow to be equivalent. If not, if the interest rate is fixed and if the times of occurrence of the sums are different, then certainly the amount of sums will also be different at different times. So, that is how equivalence can be maintained. Now, let us see, we have to judge which of the option is better. So, in the option 1, you are getting a cash flow diagram like this. You are getting ₹50,000 now. And in the second option, you are getting 8,000 rupees for the next 10 years. So, option 2 gives you a cash flow diagram like this. And every year end you are getting 8,000 rupees. Now, these are the two options which we have. Now, they cannot be compared unless you try to evaluate the amount at a particular time. Here you see that you have the interest rate fixed. The condition is that you are paying 12% interest compounded annually on a bank loan. So, basically this gives you a consideration of taking the interest rate. So, interest rate is taken as 12% compounded annually. Now, in this case you have to compare these two. So, you have to keep the three factors as we discussed in mind. One is the amount of sums, which is different here. You are being paid 50,000 in the option 1 and you are being paid 10 times 8,000, but at different times. So, certainly the time of occurrence of sum is also different, and the interest rate is taken as the fixed one, that is 12%. So, if time of occurrence is taken at a fixed point, amount should be same for the cash flow for the two options to be equivalent. That we have so far come across, that if you are taking a particular time, because time of occurrence is different here. Once we fix this time of occurrence, if we find the equivalent value at a particular time, in that case automatically the amount of sum must be fixed for the two cash flow to be equivalent. Now, this time can be either the present time or a future time. You can have the equivalent value at this point, or you can have the equivalent value at this point, and then you can compare. Now, it is better to compare using the present worth calculation. So, anyway, in this case what we see is that the present worth is rupees 50,000. Now, if you calculate the present worth value of the option 2, in that case we have already come across the different interest series factors. So, basically present worth can be found out by multiplying the annual amount with a factor P by A, and I is 12%. So, 12 and N is 10. This basically gives you the equivalent present worth of this cash flow series at this particular point. Now, so far we have used the different types of interest factor relationships to find these factor values, but we can now onwards use the interest tables to calculate these interest factor values. Now, these interest table are supplied at the back of the textbooks. Also, you can calculate on your own in the Excel. How to use it? Let us see, this is the interest factor values for different discrete compounding, that is I equal to 12%. So, in this case you have n varying from 1 to 18, and these are the different factor values. So, in this case you have to get P by A 12 10. So, if you see here P by A 12 10, this is the P by A and this is anyway 12%. So, corresponding to 10 you come here and this is 5.6502. So, A is given as 8000 multiplied by 5.65. So, this way if you have to take any value for any number of years or for any other factors, you have to just see that which is the row and column and which is the point which is intersecting, and that particular value will be directly taken from the table. So, it comes as 45,200 rupees. Now, what we see is the two cash flows are basically giving you the present worth value at a particular time. Now, what we see is its value from here you are getting P as rupees 45200. So, now you can compare these two, and obviously what you see is in the option 1 you are offered rupees 50,000, whereas in the option 2 at present you are whatever you are getting that is worth of rupees 45,200. It means option 1 is better for you. So, in this way we can come to a decision which option will be better. We can also find the equivalent value at any future time. So, suppose you want to calculate the future worth of this. So, this factor, if you go for future worth analysis at n equal to 10, in that case 50,000 will be multiplied with. So, option 1 gives you 50,000 multiplied by the factor f by p I 10. So, this will be f by p I is 12 and this is 10, and we can see further the value from here f by 2, f by p I 10 and f by p I 10 is 3.1058. So, this is 50,000 multiplied by 3.1058. Similarly, if you go for this, here the future worth can be found as A multiplied by f by A 1210. So, this will be 8000 multiplied by f by A 1210. So, it will be f by A 1210, and we will come here, this is 17.548, and after calculation you can see that this one is more than this amount. So, from this analysis also you can see that option 1 is better. So, what we see that you will have to find the equivalent value at a particular time, and then only you can compare them. Equivalence calculation using interest formula. Now, many a times you have to use the interest formula. In the interest formula normally we come across the terms like P, A, F, I and N. When we go for annual compounding, we come across these terms, the present sum, this is annual amount or annuity, this is future sum, this is interest rate, and this is number of years. Now, in the particular formula, if one of these is not given and other quantities are given, you can always find that particular unknown quantity or parameter using the expression. Now, sometimes interpolation may be required when interest rate is to be determined. So, sometimes when the interest rate is to be determined, we will see in the example, we have to basically use the linear interpolation formula. Now, let us see the first case when we can use the normal interest relationships to find a particular parameter. Suppose you have to find equivalent present sum which gives you rupees 10,000 at the end of 3 years at interest rate of 12% compounded annually. So, in this case, as we know, you have to find the p value, whereas, so to find p when f, I and n is known. So, in that case, you can find p by using the factor, and the factor p by f I n, that is p by f, and I is given as 12% and n is given as 10,000 as 3 years. So, p by f 12 3 we can further refer to the table p by f 12 3, and p by f 12 3 comes out to be 0.7117. So, it is 0.7117. This factor is to be multiplied with f. So, 10,000 f into p by f 12 3, that is 10,000 multiplied by 0.7117, that is 7117 rupees. This is the equivalent amount at present time, which will give you rupees 10,000 at the end of 3 years at this particular interest rate. So, you can say that equivalent present amount is rupees 7117. So, this is how you use these interest factors to find one of these A, P, I and N and F from the data given to you. Now, next is when you have to calculate the interest, you may have to go for interpolation. Let us see the example of this. So, a problem is given to you where P, F and N is given as 12,000, 21,000 and 9 years, and you have to find the equivalent interest rate. Basically, this will be the interest rate which will convert this 12,000 rupees into 21,000 rupees after 9 years. So, basically in these cases the unknown is interest rate. So, in this case what we see is we have f as 21,000 and p as 12,000 and n as 9 years. Now, f by p I 9, it comes out to be basically 21,000 by 12,000, because this amount when it will be multiplied with this factor, basically when p will be multiplied with this factor, it should give you the f. That is why f by p, or you can write this will be coming from this expression p into f by p I 9 should be equal to f. So, from this expression basically you can get f by p I 9, that is 21,000 by 12,000. This comes out to be 1.75. Now, although this expression is quite simple, it is nothing but 1 plus I raised to the power minus 9. So, you can directly calculate I. However, in many cases the relationship may be complex. So, let us see how you can solve it using interpolation. So, for interpolation you have to see the table in which corresponding to 9 years you have to find a value, one value which is less than this and another value which is more than this. So, for that we will refer to the table. Now, if we see the 6% interest table as corresponding to the 9 years, we get f by p I n as 1.6894. So, referring to the interest table, %, what we see is f by p 69 we see from the table as 1.6894, and further we have to see for the same number of years, that is n equal to 9, for 7% it comes out to be 1.8384. So, f by p 79 is coming as 1.8384. So, it means the real interest rate lies between 6 and 7%. The actual or equivalent interest rate lies between 6 and 7% and can be found using linear proportion method. So, the actual rate of interest will be 6 plus 1.75 minus 1.69, we are converting it to 2 point divided by 1.84 minus 1.69. So, this comes out to be something close to 6.41%. So, this way when we need, we can use these interpolation or linear proportion methods to find the equivalent value of interest rates. Now, we will discuss about some of the other principles of equivalence. The first principle is receipt or disbursement can be directly added or subtracted only if they occur at same point in time. It means if there is a cash flow and you want to find the equivalent value at a particular time, all other receipts or disbursements, their equivalent value has to be found at that particular time, then only you can add them or subtract them. Unless you convert them to that particular time basis, you cannot add them. So, we can understand it by an example. Suppose there is a cash flow Now, in this case, if you are having a deposit of suppose 1000 rupees here, you are having a deposit of rupees 200 here, you are having deposit of 100 for consecutive 3 years here, you are having a deposit of 750 for 3 consecutive years. Now, in such problems, if you have to find the equivalent value at the present time, you cannot add these quantities directly, you will have to convert its equivalent value at this particular time, and we have so far understood how can we get the equivalent value of these amounts at a particular time by using the interest factors, and suppose the interest rate is taken as 12%. So, in this case, what will be the equivalent present worth now? So, to find equivalent present sum. Now, this equivalent present sum is at present time. So, see this 1000 will be directly added. So, if it is P, it will be equal to the contribution if of this rupees 1000 will be as it is. So, this will be 1000 plus this 200 is made 2 years hence. So, its equivalent value you have to get at this time. So, this will be multiplied with a factor that is P by F, I is 12 and N is 2. This is single payment series present worth factor. So, you have paid this future amount and its present value will be multiplied by this amount. Now, we can basically individually get the present worth values of these quantities, each one being multiplied with single payment present worth factors, but that is not an intelligent way to solve it. So, what we see is this is an equal payment series. So, basically we can find its equivalent value either at this time or at this time. If we try to find its equivalent value using the future time concept, this at this time you will get the equivalent f for these 3 amounts. But if we try to get the present worth component using these 3 amounts, we will get its value at here. So, if suppose we use the f by a formula, so 100 will be used f by a 12 3. This will be the equivalent amount at this point 100 f by a 12 3. Now, this point where it has to go here. So, this will be again multiplied with p by f 12 6. So, this amount will be multiplied with p by f 12 6. Now, left is these 3 amounts. Again these 3 amounts can be done in the similar fashion. So, 750 multiplied by f by a 12 3, this will give you the amount here. And again this is to be sent here. So, this is to be multiplied with p by f 12 10. So, it will be into p by f 12 10. So, what we saw is, if this is A, if this is B, and if this is C, so this will be the contribution of A. Similarly, this amount when multiplied with p by f 12 6, as we have done here, this amount will be contribution by B. And similarly, this amount again multiplied by this factor, it will be contribution by C. In this case, what you see is, you find the equivalent value at the present time, and since 1000 is there already at the present time, you can directly add. So, what we see is that the receipts or disbursements, they are directly added, but for that you have to convert them at a particular time in future, and this time is the present time. And once we do the calculations, you can get the values 1000 plus 200 p by f 12 2. So, we can refer to this, p by f 12 2 is 0.797 plus 100 into f by a 12 3. So, f by a 12 3 is 3.3744 multiplied by p by f 12 6. So, p by f 12 6 again we can get from here 0.506 6. So, 0.507 plus 750 multiplied by f by a 12 3, f by a 12 3 we have got 3.374 and p by f 12 10. So, p by f 12 10 will be 0.3219. So, 322. In this case we can get the value 1000 plus 159.4 plus this is 171.06 plus 750 multiplied by 3.374 into 0.322. So, this is 814.82. So, once we add them it comes out to be 2145.28. So, what we see is that an amount of 2145.28 is equivalent to this particular cash flow. At this time we have converted all these cash flows at this time and then we have added them and we got this answer. Next is when cash flows are converted to their equivalences from one period to another, interest rate during each period must be taken into consideration. So, basically this we will discuss next when we will see that how the interest periods in the different rates in different periods have to be taken separately while calculating their equivalent values at a particular time. For then, thanks.